Okay, so let's talk about imaginary roots. Kind of a weird thing like imaginary, but before we talk about imaginary roots, let's go back through the definition of a root. A root is any value that makes a polynomial equal to 0. Any value. So I took a look at an example, the same one we did on our warm-up, and we ended up factoring this, and then we know that our roots are at x equals 0, x equals -5, and x equals 5. Because I plugged 0 in, we get 0. If I plug 5 in, I get 125 minus 125, I get 0. -5, I get -125 plus 125 is 0. So these are all zeros because when you plug them in, they make the polynomial 0. But then we took a look at something like this, x squared plus 4. Now we know there has to be two answers, but if you tried to solve x squared plus 4, it won't work, okay? In fact, if you looked at the graph of this, basically is up at 4, and it does not cross. But there has to be two answers, but they're not real answers. So we start, okay, let's back up and talk about what is an imaginary root. So first, let's start with an imaginary number. The square root of -1. Let's just go right there. First of all, square root of -1 it doesn't work. You can't take the square root of a negative number, so we call it I. So whenever you see the square root of -1, it's I. It's imaginary, okay? So then from there, what we can do is do some other examples. Square root of -4 is 2i because the square root of 4 times square root of -1 is the square root of -4. The square root of 4 is 2, so we get 2i. Now, if that's the case, well, let's take a look at this one a little bit more. Let's talk about taking this answer and square it. Okay, you'll see why I squared it. 2i squared is 2i times 2i, which is a 4i squared. Now, I is the square root of -1. So what is the square root of -1 squared? Well, squares cancel the square root, which makes -1. 4 times -1 is -4. Okay, well, if I were to plug that into my equation, I get 0. Okay, that makes 2i and -2i. So if I plug that in, 2i, into my equation, and I'd have then 0 equals 2i squared plus 4, we know that we'd wind up with an answer of 0. So, therefore, 2i and -2i, have to have two answers, are roots. But they're not real roots, they're imaginary roots, okay? So we did a couple of examples, okay? First of all, we took a regular old factoring, and we factored x to the 4th minus 2x squared minus 8. If I'm looking for the zeros, I set it equal to 0. I factored x squared minus 4, x squared plus 2. And then what I did is I was able to solve this one pretty easily. Set it equal to 0. Many equations, I add 4. Took the square root. Square root of 4 is 2, but two answers, plus or minus 2. Here, though, I subtracted 2. I got -2. And when I take the square root, I'm going to have the square root of a negative. I can't have that. It's not real. So I broke it up into the square root of 2 times square root of -1. We learned that the square root of -1 is I. So I've got plus or minus the square root of 2i, because I can't take the square root of 2. It's just a bad number. Okay? Then I went to example 3. I did by grouping. We did by grouping before. I set it equal to 0. We did grouping. Set it equal to 0. We have 4 terms. Group. I took out an x squared. X minus 3. I took out a 5 from this group. X minus 3. They both have an x minus 3 in common. So then I have my x minus 3 times my x squared plus 5. My many equations. This one's easy. Plus 3 plus 3. This one's a little harder. I go minus 5, but I have to take the square root of a -5. We can't do that. Broke it into the square root of 5 and the square root of -1. We know that's I. So I get the square root of 5i. Okay, and that's all I have for today. So we're going to use that in finding all roots with polynomials, real or imaginary.